I'm going to explain about special registers of Cortex M3 process. In Cortex M3 process, we have mainly three special purpose registers. So the first one, it's called as program status register. The short form is called as PSR. And second one, interrupt mask registers. Within these interrupt mask registers, again we have three classifications. I will discuss you later. And the last one is control registers. So what is the use of special registers? The special register role is very important in microcontrollers to perform a specific operations. What kind of operation it is? For example, so here we look into these three types of special registers. Program status registers to monitor, to find the status of the program. Zero flag is generated or not, negative flag is activated or not, carry flag is activated or not, or it can be generated or not. So like this, some specific operation is performed by these special registers, or sometimes it's called as special function registers. Okay, these three special function registers or functions can be accessed only by special instructions. So general instruction is not allowed to access these special instructions. Only some set of instructions is available to access these instructions. In these today's sessions, I will going to explain about even some special function registers and some instructions. What kind of instructions support for this to move the data from special register to the general purpose registers and general purpose register to the special purpose registers. Okay, now we're going to discuss one by one these sessions. So first I'll come to that the list of these three special registers: program status register, interrupt mask registers, and control registers. So it is these same registers for these representation in the mnemonics. We are going to express XPSR, that is called as program status register, primary mask, PRI mask. It is a one type of register from interrupt mask registers, fault mask registers, base PRI. It belongs to these three belongs to the interrupt mask registers, and the last one is control registers. So here, no, don't confuse these. Special registers mainly three types: program registers, interrupt mask registers, and control registers. Interrupt mask registers, again we have three classifications. That is what we mentioned: PRI mask, fault mask, and last one base PRI. Okay, now we're going to discuss these functions of these special registers. What about the first one, program status registers? It provides arithmetic and logic processing flags, for example, zero flag and carry flag, their execution status, and current executing interrupt numbers. This is the main function. It belongs to that program status registers. And second one, it comes to the interrupt mask registers. In the interrupt mask registers, we have three sub registers. PRI mask. First one, it is PRI mask. So disable all interrupt except the non-maskable interrupt and R fault. So the function of this PRI mask, it disable all interrupts except the non-maskable interrupts. And second one, it is fault mask. It disable all interrupts except the non-maskable interrupt. Okay. Then base PRI. It disable all interrupts of specific priority levels or low priority levels. That is what base PRI. Base PRI full fault mask and PRI mask belongs to the interrupt mask registers group. And here the functions also as specified. And the last one it is control registers. So these control registers define the privilege status and stack pointer selections. So here we have two modes of operation, user mode and privilege mode. So here it defines these control registers. It is equal to 1 and it is equal to 0. You'd have perform some specific functions. Okay. So I'll going to discuss these functions one after the others. Okay. So now I'll come to that. What kind of registers support or what kind of instructions support for to read the data from special registers or write the data from special registers. So commonly these two instructions they support for to read or write the content into the special registers. That is what one it is called as MRS. So that is apparent. REG is the register for destination apparent. Then special registers. So here the content of the special register moves to the registers. Special registers is a source, register is a destination. In first instruction, MRS. Okay, read special registers. And similarly, in the second instructions, it support for the content write to the special registers. The previous one, read the content from special register to the register. It belongs to the instruction MRS. And second one is MSR. The content from register to the special registers. Okay. So sometimes in the comments it will be written as write to special registers. Of course, the content from register to the special registers. Okay. So then I'll come to that one by one. Operation of special registers I'll going to discuss. First, I will take program status registers. In this program status registers, again subdivided into three status registers. What are those status registers? The first one it is called as application program status registers, APSR. It is called as application program status registers. Second one it is called as interrupt program status registers. So it support for that it will find the status of that interrupts, what are the interrupts are executed and what their roles, everything. Yeah, every instruction status to be find out by using IPSR. This is interrupt programs status registers and the execution program status registers. The last one comes to that execution program status registers. So these three registers role is very important in any programs. So each registers they have the bit configurations also. Some bit status set and reset operations I am going to discuss in future slide. These three program status registers can be accessed together or separately using these instruction, same instructions MSR and MRS. These two instructions we are going to use to access separately or access together with program status register. Together with means all these three status registers. So now I'll come to that bit configuration of program status registers, interrupt program status registers, execution program status registers. So we club together all these three, we can represent it in the single bit configuration also. Now, so all of you please look into these here. The first we highlighted 5 instructions. What were these 5 instructions? So MRS means from special function register to registers. It means that read flag status into R0, first one. Second one, read interrupt state into the R0, read execution state into the R0, and then write flag state into the write flag MSR. It is the opposite. So the content from R0 to special registers called as application program status registers. So very clearly all these 5 instructions indicated like this. Suppose we can read or sorry, we can write that even interrupt program status registers or execution program status registers. We can use MSR, IPSR, R0, MSR space, EPSR, R0. We can use like this. Now we'll come to that. So we have separate bit configurations. First one, it is called as application program status registers, APSR. We have 5 parameters. So that 5 parameters. So please look into these 5 parameters. Okay. So in these 5 parameters, n is in the last bit, n it belongs to that negative, z is belongs to 0, c is belongs to carry or borrow, and v is belongs to overflow, and q is belongs to sticky status flag, means it is a status flag. Mainly we have these 5 flags are available. All 5 flags explanation also I explained that negative flag, 0 flag, carry or borrow flag, overflow and saturation flag. These are the flags. Role is very important. In any program, in the application program status registers, if you want to write any program, I want to know the status of the program by using these are the status registers. These status registers set and reset operations, it will be defined or decided based on their working principles or working of the programs. Okay. Now similarly, I will look into that second program status register. It's called as interrupt status registers. So what for these interrupt status registers? So the interrupt status registers is nothing but exception numbers. How many exceptions are there? All these exceptions we are looking to that. Okay, that is called as IPSR. This is what exception numbers. This is also belongs to that program status registers only. Okay. Now the last one, it is called as execution program status registers. In the execution program status registers, mainly have 3 bits. We look into that. One, it is called as ICI or IT. It means that interrupt continuable instruction, ICI, interrupt continuable instruction bits, or IT means if then instructions. In the second module, during the instructions, so I will explain how it is working if then instruction in Cortex M3 process. And another one is there for T. T for thumb state. Always it is 1. Of course, this controller with support for thumb state, always look into that one. So trying to clear this bit will cause the fault exceptions. Suppose if t equal to 0, so it will cause a fault exceptions. So exception number indicates which exceptions the processor is handling. Okay, so all these 4 we can club together. So we can using for like this. Within that 32-bit configurations, we can club together all program status registers. This option also is available. So that's what I told you in the beginning. Sometimes we required to read the data from special function register to the registers or register to the special function registers. By the time we can use individually or together. So that is what the option is available. Okay. Now these are the things in the previous continuation from the previous slide. What for this n negative, z for 0, c for carry, borrow, v for overflow, q for saturation flag, ICI for interrupt continuable instructions, IT for if then instructions, and then exception numbers. And similarly, we are using these two instructions. One is the MRS, read the content from special register to the registers, and MSR, read the content from register to special registers, or write the registers, read from the registers. First one is MRS, we can read from the registers. The second one, MSR, write to the registers. Okay, now I'll come to that. PRI mask, it is interrupt mask registers. All these 3 interrupt mask registers I will going to discuss one by one. What do you mean by PRI mask? So if it is set or reset, if it is equal to set, the set means if it is equal to 1, when it is set, it allows non-maskable interrupt and the odd fault exceptions. By the time all other interrupts and exceptions are masked, the default value is always 0, or otherwise it is 0 reset, which means that no masking is available. Second one, it comes to the fault mask. Again here also set and reset operation. If it is set, it allows only non-maskable interrupts, and all interrupts and fault handling exceptions are disabled. If it is 0, which means that no mask is set. And the last one, from the interrupt mask registers, base PRI. These registers of up to 8 bits, it defines the masking priorities level. When this is set, it disables all the interrupts of the same or lower level. Higher level interrupts can still allowed. If there is set to 0, the masking function is disabled. This is what the functions from the interrupt mask registers. Okay. Then I'll come to that. All these 3 interrupt masks with instructions how to read it or how to write into that special function registers or special registers. So this is what we are going to clarify with the following instructions. These are all instructions are available. Okay. Now, and many times I explain the same instructions. So please refer the textbook. You can understand. But in Cortex M3 process, we have only 2 instructions available: read or write to the special function registers. I can read the content from special registers, or either I can write to the content to the special registers. We have only two options, or two registers, sorry, two instructions are available, that called as MRS and MSR instructions. Okay. Now I'll come to the last part of the special registers. It is called as control registers. The control registers is used to define the privilege level and the stack pointer selections. These registers have only 2 bit, either it may be 0 or it may be 1. Control bit is 0 and control bit is equal to 1. If the control bit is 1, means control 1 bit is always 0 in the handler mode. However, in the thread or base level, it can be either 0 or 1. Because in some of the operation, handler mode and user mode, either you can go for handler mode or it may be used for user mode. Then comes to that control 0. The control 0 writable only in the privilege state. Once it enter the user state, the only way to switch back to privilege is to trigger in the interrupt and change this in the exception handlers. So this is the major role and contribution to the control registers. Okay, this is the last part of the special registers. So here again the same thing. In the control registers, I can use 1 for alternate mask is used, 0 for default stack. And then if it is control 0, is privilege in the thread mode, or 1 is user state in the thread mode. So this is what the overall operation of the stack pointers. Sorry, not stack pointer, special function registers. So special function registers, they perform very specific operations. It is available in all the controllers. Almost 90% of the controllers, they have the special functions registers. But in Cortex M3 processor, these special function registers, they perform very specific operations. Okay, thank you. So next class, I will continue with some more explanation in the Cortex M3 processor, maybe operating mode or in the nested vector interrupt controllers. So many informations I will going to discuss within future slides, future sessions. Okay, thank you. Thank you very much. Thank you, one and all.